In this video, I'm going to test your understanding of atomic structure with 10 rapid-fire questions. Pause the video when you need to, and think before I reveal the answer. Question 1. What are the three subatomic particles? If you don't know this instantly, you're not ready for the rest of the topic, so go back to video 1 and watch it fully. The three subatomic particles are protons, neutrons, and electrons. These three build every atom in the universe. Every atom is built from these three particles. Protons and neutrons sit together in the center of the atom. That center is called the nucleus. Electrons move around the outside. They move in energy levels, also called shells. So picture it clearly. A dense nucleus in the middle, and electrons moving all around it. That structure is the foundation of everything in chemistry. Question 2. Which particle determines the identity of an element? Not its mass, not its charge overall, its identity. What actually makes carbon, carbon, and oxygen, oxygen? The answer is protons. Only protons, nothing else. The number of protons in an atom is called the atomic number, and the atomic number defines the element. If an atom has 6 protons, it is carbon. If it has 8 protons, it is oxygen. If you change the number of protons, even by 1, you create a completely different element. Neutrons can change, electrons can change, but if protons change, the element changes completely. This is the single most important rule in atomic structure. Memorize it. Question 3. What does the mass number represent? Not the atomic number, not just protons, the mass number. What is it actually counting? The mass number represents protons plus neutrons together, nothing else. The mass number counts the particles in the nucleus only, and the nucleus contains protons and neutrons. Electrons are not included. Why? Because electrons have an extremely small mass compared to protons and neutrons, so small that at GCSE level we completely ignore them. So remember clearly, atomic number equals protons, mass number equals protons plus neutrons. If you can separate those two ideas confidently, you'll avoid one of the most common exam mistakes in atomic structure. Question 4. An atom has atomic number 12 and mass number 24. How many neutrons does it have? This is where people mix things up. Slow down and think carefully. The answer is 12 neutrons. To find neutrons, we use this rule. Neutrons equals mass number minus atomic number. Mass number counts protons and neutrons. Atomic number counts protons only. So if we subtract atomic number from the mass number, we remove the protons, and what's left? The neutrons. In this example, 24 minus 12 equals 12. So the atom has 12 neutrons. You will see this calculation again and again in exams. If you remember one formula from this lesson, make sure it's this one. Question 5. If an atom is neutral, what is the relationship between protons and electrons? Neutral means there's no overall charge. The number of protons equals the number of electrons. Protons have a positive charge of +1. Electrons have a negative charge of -1. If an atom is neutral, it has no overall charge. That can only happen if the positive charges and the negative charges cancel out. So the number of protons must equal the number of electrons. For example, if an atom has 8 protons, it must have 8 electrons to be neutral. If those numbers are not equal, it is no longer an atom. It becomes an ion. Question 6. What are electron shells also known as? You might have heard 2 different terms for the same thing. So what is the scientific name? Electron shells are also known as energy levels. Electrons do not just float randomly around the nucleus, they sit in a specific energy level. These are regions around the nucleus where electrons are allowed to exist. The first energy level is the closest to the nucleus. The second energy level is further away. The third is further still. Electrons always fill the lowest energy level first. So they fill from the inside out. First shell fills, then the second, then the third, getting further from the nucleus each time. This idea is extremely important because electron configuration and eventually chemical behavior all depend on these energy levels. Question 7. What shell capacities do you actually need to remember at GCSE? Not university, not A-level, just GCSE. What numbers matter? The only numbers you need to remember at GCSE are 2, 8, 8. The first shell holds 2, the second shell holds 8, the third shell also holds 8. At GCSE level, you only need to worry about the first 3 shells. The first shell can hold a maximum of 2 electrons, the second shell can hold 8, the third shell can also hold 8. That's it. Do not overcomplicate this with A-level values such as 18 or 32. Examiners at GCSE are not testing that. They want 2, 8, 8. If you remember those 3 numbers, you can write electron configurations for the first 20 elements, and that is exactly what they expect. Question 8. What is the electronic structure of sodium, which has 11 electrons? We already know the shell capacities are 2, 8, 8, so now we apply them. Let's build it step by step. The electronic structure of sodium is 2, 8, 1. Sodium has 11 electrons. The first shell can hold 2, so we put 2 there. That leaves 9 electrons. The second shell can hold 8, so we filled that completely. Now we have used 10 electrons. There is 1 electron left over. That goes into the third shell. So the electronic structure is 2, 8, 1. And that final 1 is extremely important, because that single outer electron is what makes sodium reactive. We will come back to that when we study Group 1 elements. Question 9. Which particle is mainly responsible for chemical reactions? Is it protons, neutrons, or electrons? Think carefully about this one. The particle mainly responsible for chemical reactions is electrons, specifically outer shell electrons. Chemical reactions involves atom gaining or losing or even sharing electrons. Protons do not change. Neutrons do not change. If protons changed, the element itself would change. That only happens in nuclear reactions. At GCSE level, chemical reactions are about electrons, more specifically, outer shell electrons. Those outer shell electrons determine how reactive an element is, so atomic structure directly links to bonding, and bonding explains chemical behavior. Why are electrons ignored when calculating mass number? We know mass number counts particles in the nucleus, but why don't electrons matter? Electrons are ignored because their mass is extremely small, so small that it makes almost no difference to the total mass of the atom. But how small is small? An electron has about 1,836 the mass of a proton. That means a proton is 1,836 times heavier than an electron, so when calculating mass number, the electron's mass is negligible. In GCSE chemistry, we treat it as 0. That's why mass number only counts protons and neutrons, because they contain almost all the mass of the atom. Atomic number counts protons. Mass number counts protons and neutrons. Electrons do not meaningfully contribute to atomic mass. That's 10 rapid fire questions. If you're scoring 8 or more, you're exam ready. If not, rewatch and tighten the gaps. Next topic will be coming up. Subscribe if you're serious about improving your grade. Mr. Knows, knowledge beats luck.